Two metal plates are each loaded with 2 coulombs of electrons and placed 3 millimeters apart. Using Coulomb's law, calculate the force between the two plates. Is this force attractive or repulsive? How far apart must be the plates be moved to reduce the force by a factor of 120? First, we have to write down everything what is given. We have given two charges, Q1 and Q2, both of them are 2 coulombs. We have distance between these two plates, 3 millimeters, and we have proportionality constant 9 times 10 to the 9 Newton meter square over Coulomb square. We have to find the force, and we're supposed to find the distance in the third part of the problem. We're supposed to use the Coulomb law formula. So, what we are going to do? First, please realize that the distance between two plates is separated by 3 millimeters. What I'm going to do, I'm going to draw the diagram first. We have two plates. One plate is loaded with Q1, 2 coulombs, and second plate, Q2, 2 coulombs. And the distance between two plates is equal 3 millimeters. We have to find force between these two plates. Formula says F is equal proportionality constant times Q1 times Q2 over the distance square. K is equal 9 times 10 to the 9th Newton meter square over Coulomb square times Q1, which is equal to coulombs, times Q2, which is equal to coulombs, over my distance is already expressed in meters. So I can write over here 3 times 10 to the negative 3 meters, because milli represents the power of 10, and we have meters. Everything has to be squared. And I have 9 times 10 to the 9th Newton meter square over Coulomb square times 4 Coulomb square. Coulomb square and Coulomb square will cancel out, over 3 to the second power is equal 9, and I have negative 3 times 2 gives me negative 6 times 10 to negative 6 meter square. Meter square and meter square will cancel out. 9 and 9 will cancel out. And let's take a look what we have. We have 10 to the 9th over 10 to negative 6. Remember, anytime we have division and we have the same base, we're supposed to keep the base and subtract the exponents. That's why I'm going to have answer, my F, is equal 4, because 4 is going to stay, times 10, and I have 9 minus negative 6 newtons. This is equal 4 times 10, negative times negative gives me positive, and I have 9 plus 6 gives me 15 newtons. And this is the answer for part A of my problem. The force between these two plates is going to be equal 4 times 10 to 15 newtons. Next, we're supposed to find out if this force is attractive or is repulsive. Because my answer is positive, it means that the force is repulsive, because we have two positive charges. Anytime we have two positive charges, they're going to repel each other. If one of them would be negative, they would attract. Remember, when we have positive and negative, they attract each other. So because we have positive value of my force, that's why this is the repulsive force. This time we will find out how far we must put these two plates apart in order to reduce this force by 120. So what I'm going to do, I'm going to write this formula one more time. I have F equals K Q1 Q2 over R squared. But this time I have to make sure that my force is going to be weaker 120 times. That's why I'm going to write F over 120. And I have to find the distance. This is proportion. In order to solve proportion, I have to cross multiply. I have F R squared equals 120 K Q1 Q2. I have to find R. I have to divide both sides equation by F. F and F will cancel out. I have R squared equals 120 K Q1 Q2 over F. But I'm not looking for R squared, I'm looking for R. In order to eliminate this exponent, I have to square root both sides of my equation. Square root is going to eliminate my exponent. And I'm going to end up with formula R is equal square root, open parenthesis, 120 K Q1 Q2 over F. This is equal square root of 120 times 9 times 10 to the 9th Newton meter square per Coulomb square. Q1 times Q2. 2 times 2 gives me 4 Coulomb square over 4 times 10 to 15 newtons. Coulomb square and Coulomb square will cancel out. 4 and 4 will cancel out. Newton and Newton will cancel out. And I'm going to end up simply with 120 times 9 times 10 to 9 over 10 to 15. M square. M square in the numerator. If you are going to plug in these values into the calculator, you are going to end up with 32.86 millimeters. This is the distance between two plates at which this force, which we find originally, is going to be weaker 120 times.